Okay, hello everyone. Today we're going to be going over contain duplicates, a leak code question. It's a pretty easy one, but it's an important one. So, given an array of integers, find if the array contains any duplicates. So, you'll notice we're only seeing if the array contains any duplicates. We're only returning true or false. We're not returning the actual element that's a duplicate, or like the first element. We're just returning true or false. And we return true if any value appears at least twice in the array, and returns false if every item is distinct. So if you look here, 1 appears twice. We have a 1 here, we have a 1 here, so we return true. Here, everything's distinct. Here, 1 appears like 3 times, 3 appears 3 times, 4 appears twice, and even 2 appears twice. So everything's a duplicate there. So we definitely return true here. So we return true if there are any duplicates. So there are two good solutions for this. The first, that's actually kind of easier to think of, in my opinion, is to use a set. So in Python, this is how you would initialize a set. And sets are useful because you can have like constant like search time. Like if you want to search if an item is in your set, you just hash it. You see if that hash is in there. Well, that hash mod the size of your hash bucket. If you've taken 61B, you would know what that means. Like you just go to that location. If you find it there, then you have the item you're looking for. Otherwise, you know it's not there. So if our set S here, I'll just put this in a comment for now. Like let's say it's the items 1, 2, 3, 4. Then something you can do is you could, in Python, you could say like if 1 in S, and this would return true because 1 is in here. And if you say like if 5 in S, this would return false because 5 is not in the set. But this is how it would appear if you printed in Python, if you print a set in Python, and this is how you work with sets. You can use the in operator. Yeah, so and you can, if you want to add to a set, you can just say s.add and then whatever the value is. If you wanted to add 1 to your set, you could just say s.add1, no semicolon. You don't need a semicolon in Python. But yeah, so then what we could do is we could go through every value in nums. So we could say for value in nums, and what we could do is if the value is in s, then we can return true because because we're adding everything to. We're adding every value to our set S, and if the value is already in there, that means it must be a duplicate because it's not a distinct value. It's not something we haven't seen before. And if we go through like the entire nums list, if we go through the entire list and we haven't seen any duplicates, then we can conclude it is an array or a list of all unique elements, all distinct elements, and then we can return false because we know there are no duplicates. If there were, we would have seen it when we added it. And if we run this, you'll notice it should work. Yeah, okay. This is nice and all. There's actually there's a nicer way to do this exact same thing. You could just say return len of nums is not equal to len of set of nums. And this will do the exact same things. You notice here it took like 40 milliseconds. This takes like 44 milliseconds on like this one input. Let's see overall. Overall, it does a bit better. It takes 112 versus 116. It's not that much of a difference, but something I will say is that like if you look at these two, like here, wait. If you look here, this the top one is fast. Like the bottom one is faster, like given through these tests, but like, and they are both O of n space. They both have to go through the entire things. But here that's not actually entirely true because here you stop as soon as you see the first duplicate. Here you add every single thing to the set. This inherently like converts the nums list to a set and then takes the length of it. So since over here you're converting everything to a set, this technically takes up more space complexity. It has like a larger constant. Like these are both O of Cn, which is in O of n for like space complexity terms. But but this will always have a constant of one. This bottom line will always have a constant of one, while the above will always have some constant that's between 0 and 1. Because if you look at like this example, as soon as it sees 1, 1, it will end in two elements. There could be like a million things in this array, but it would only end in two elements. So this is actually a bit faster there, but in the long term, like Python is so optimized that like this solution works out well. I think this is the best solution in my mind. But there, if you guys want to see, there's also there's also a sorting solution. It's pretty simple. You just do like nums.sort and then like iterate through them and see if you see two things next to each other that are the same. Then you know that you must have a duplicate because and that requires you to only have constant space because you only store like the last element. Well, you don't even need to store it. You can just access it if you go up to nums.length -1. So if you end your for loop a bit early to not go out of bounds, that works. But this is n log n time complexity at the cost of space complexity. At the benefit of space complexity, you lose some time complexity because you have to sort the array. So I like this because you don't actually have to change the array. You don't have to mutate it. So, but they're both valid approaches. So stay tuned for the next one.